Thank you for joining us today on our webinar. So today we're going to be covering, journey to a modern active-active architecture with CockroachDB and Google Cloud. And as part of that, we have a pretty full agenda. So we're going to be talking about the key trends, tackling challenges with within those trends with CockroachDB and Google Cloud, a technical intro to CockroachDB for those of you who are not that familiar. And then we have our speakers from Global Payments. They're going to talk about their modernization journey to an active architecture on Google Cloud with CockroachDB. Then I'm going to circle back and talk about the partnership between Cockroach Labs and Google Cloud and how you can get started with us as well. So having said that, let me go ahead and introduce our speakers today. So I'm Hersh Shah. I'm a partner solutions engineer here at Cockroach Labs. Along with me today, we have Ajay Goyal, who's our senior database developer at Global Payments. And we also have Don Bosco from Global Payments, who's the principal database administrator there as well. And we also have Stephen Richardson, who's our staff technical consultant at Google Cloud, who supports the Cockroach Labs partnership. Thank you all for joining us today. And if you have any questions, feel free to leave them in the chat using the Q&A feature that we have, and we'll try to address them either live or at the end of the session, whichever way that's possible today. So thank you again for joining us. Having said that, okay, so we're going to cover some of the key trends and challenges that companies are facing today, and they're looking to resolve by moving, to a cloud native approach. So some of the trends that you see with companies today is they want to, first of all, modernize their application infrastructure. They're moving off of on-prem systems to the cloud to really take advantage of that dynamic scaling up based on demand and dynamic scale based on that demand, right? And then also getting into making sure that they can maintain always on availability or high availability architecture and serve a global customer base and provide a great user experience no matter where their customers are, and guarantee consistent transactions, a consistent experience, while at the same time navigating complex regulations. And one of the ways that they're doing that is they're moving their on-prem data centers, taking that cloud journey, going to the cloud. And by leveraging Google Cloud, what they're looking to do is, ease off that managing of their own data centers and make it easier by using the cloud there to make it simpler to manage the infrastructure, using the cloud resources and the cloud native architecture to scale, architect for scale and achieve zero downtime, take advantage of the multiple regions that are provided to, scale their applications across different regions while making sure that they're giving a great performance for users everywhere. They're located everywhere across the globe and taking advantage of those first-party services that are available for better governance, security, compliance, and not. But having said that, one of the things that they also need to address is not just from the application perspective. They're taking that journey, they're modernizing their application, but they also need to modernize their database to complete the entire picture, right? To make sure that it's fully modernized. So that's where I want to introduce you to CockroachDB. So for those of you who are not familiar, CockroachDB is an OLTP transactional database built for tier 0, tier 1 applications. And it's built to be consistent, resilient, take advantage of distributed workloads and be easily scalable. And what does that mean to you as a user? So what CockroachDB is it takes the best of a relational database, the familiar SQL interface, being compatible with Postgres. Like basically, it's wired compatible with Postgres. So to you as a user, it looks and feels like Postgres, but at the same time, being ACID compliant, making sure it supports transactions and those features that you get with relational databases, but merging them with the capabilities of a NoSQL database, like the scalability, online schema changes, being able to perform no downtime, upgrades. At the same time, it needs to be built to be cloud native. Take advantage of that multi-region AZs that you get on the cloud. Make sure that you can take advantage of those architectures by being natively distributed in its architecture, and account for elastic scalability while giving enterprise-ready features such as PCI, being HIPAA and GDPR compliance, providing features such as data locality and data domiciling within the product itself, making sure that's enterprise ready for those tier 0, tier 1 use cases. So taking a step back from that, so to you as a user, CockroachDB looks and feels like Postgres. So if you're familiar with Postgres, your experience using CockroachDB, even though it's a distributed database, is going to be very similar in that sense. But the difference here is it scales like a NoSQL database. So CockroachDB, being a distributed database, it starts off being distributed across several nodes. But let's say you're approaching your threshold. How do you scale your database? Just by adding nodes to your CockroachDB cluster. And you're scaling not only your compute, but also the volume of data that your database can handle. And this while being a single logical database, not different data centers and whatnot. And because you can scale horizontally so easily, it enables us to take advantage of that, cloud native infrastructure and, scale across multiple regions across US, Europe, Asia, all while being a single logical database still. Traditionally, with traditional databases, you would have to think about establishing different data centers and managing complex replication across those different data centers to ensure consistency. With CockroachDB, it's all built in. We simplify that process for you. And any node within CockroachDB can read and write data. So it's a truly active architecture. So for example, you have a user that writes into node 1, but at the same time, a user can connect to node 3 and write data as well, because every node within CockroachDB is a peer. It's basically can act as a gateway node to handle those transactions that are happening. And the data within CockroachDB is always consistent. So what we implement within CockroachDB is we implement consensus-based transactions, making sure that everything you write within the database is consistent. So at a default, we provide serializable isolation, which is the highest level of isolation or consistency possible within transactional database. So to ensure that you get consistent transactions every time and your data remains consistent. So no matter if you're writing to node 1 or node 3 or whichever node they're writing or connecting within CockroachDB, your experience using it and is always going to be consistent. And data is always available. So what we do is we distribute the data within CockroachDB into chunks, and we replicate it all across the cluster. So no matter which node that you're interfacing with to retrieve the data, doing user select queries, data is always available. And we're going to speak to availability a little bit more as well as part of how it's resilient, right? So there's a reason it's called CockroachDB, and I'm going to touch upon it pretty soon. And what that basically what that horizontal scale and the replication of that data, what that enables you to do with the database is handle failures without downtime. Let's say you had a node that had a disk stall, or for some reason you had an asymmetric network partition where that node is unavailable. Because we implement consensus-based transactions, your database is still available to serve those transactions, still available without downtime. So you still have a majority of those nodes available to process your transactions in that case. But let's say you need to, handle a more critical failure. Let's say you can always scale your database cluster across more nodes and more regions to basically create a topology that serves your purpose to survive the type of failures that you as an organization need to survive. And with that, because of our distributed nature, we can upgrade without downtime as well. So let's say you start an upgrade for the database cluster. The entire cluster, similarly to what you saw previously, with let's say it's unavailable and you had a failure. Similarly, if you're upgrading the cluster, you upgrade one node at a time, and it's rolling upgrade that goes across the cluster, making sure the majority of your cluster is always available to serve transactions. So basically, while your cluster is going an upgrade, it's still able to process incoming transactions without downtime for your applications, right? And that's the reason why we're named CockroachDB, because as a database, it's really hard to kill us. It's really hard to, just basically bring the database down. So like a cockroach, you can maybe kill one cockroach, but you can't kill them all. Similarly with the CockroachDB, because it's a distributed database, maybe one node goes down, but the database at its core remains available to the application, to serve the application and the users. And similarly with schema, like schema changes and whatnot, those all occur without encountering any sort of downtime within the application itself. And because of that scalability and consensus-based transactions, you're able to read and write data across multiple regions within those same consistency guarantees as well, in terms of those transactions that you're trying to do, even though it's a multi-region cluster. Even though those are going across multiple regions, you still get the same transaction guarantees, making sure that your transactions, your inserts, your updates, they're all ACID compliant. And your reads at the same time are also consistent as well. So what that allows you to do as an organization is not only scale the cluster to multiple regions across the globe to serve a global user base that you may have as an organization. It also lets you pin data to geographies uh, to comply with regulations such as GDPR, for example. If you need to pin, European user data to EMEA, to your servers in Europe, you're able to do that with CockroachDB while still having a single logical database that spans across the different geographies. So while your database, you still have one database, your data for those users remains pinned to certain geographies. But that's not just for compliance purposes. That can also improve performance because you're reducing the latency by placing that data closer to the end users as well. And one of the things that we wanted to touch on was how CockroachDB works on Kubernetes, right? Being a distributed database, it really takes advantage of its cloud native architecture to really be deployed on Kubernetes as well. So it's a single CockroachDB image for everything because every node is an equal. You can deploy CockroachDB on Kubernetes. For example, here with Google, we do it with GKE through their operator, Helm chart, or manual configs such as stateful sets and whatnot. And because of that, what that gives you, and with the architecture that gives you, is the ability to really take advantage of that containerized infrastructure. Because we're distributed, we're not going to be a monolith sitting on top of a Kubernetes pod, right? We're going to be a naturally distributed database with the way that we're architected to take advantage of that scale out possibilities that you have with Kubernetes as well. And with our operator, you can deploy CockroachDB. You can manage the scaling the cluster up and down on the with the operator as well as supporting rolling upgrades and providing inbuilt resilience by surviving pod failures via our operator. So having said that, what are the use cases that CockroachDB really excels in? So because we're an OLTP, a transactional database for tier 0, tier 1 applications. Companies really use us for their mission critical applications regarding storing metadata, user account data, payments, payment processing, identity management, e-commerce, inventory management, anything that requires a system of record type requirement where ACID compliance is a must is a use case where CockroachDB naturally excels in. And you see some of the logos here. Those are some of the companies that do use us for their mission critical workloads. But we have global payments here as well to speak about their journey towards an active architecture on on Google Cloud with CockroachDB as well. So I'm going to introduce Ajay, our speaker from Global Payments, to take it away here.
Thank you, Harsh. Hi, everybody. I'm Ajay Goyal from Global Payments. I'm going to talk about what Global Payments is doing with CockroachDB, why we chose CockroachDB, and our journey on modernization. So to talk about what we do, imagine you go to a shop or a coffee shop. Let's say you go to a Starbucks, you buy a nice cup of coffee, a cappuccino, and then it's time to pay. So you take out your credit card and swipe the credit card on the credit card terminal, right? And what happens in this diagram over here, you are the customer. And when you swipe the card on the merchant, in this case, it would be a Starbucks, that terminal or that point of sale system then sends a request somewhere, right? So it sends a request to us, which is a payments gateway. We take that information, we do our initial check that, hey, is it a valid credit card? If we detect for some fraud patterns, if there are any fraud patterns, and then we take that and send it forward to who that card belongs to. If it's a Visa and MasterCard, we will send it to the appropriate company, and Visa or MasterCard will then send that request back to the bank that issued your credit card. Now, your bank will check your balance, send the request back to Visa or MasterCard. They send the authorization back to us, and then we send the authorization back to the merchant. Now, that's a long chain of events that is happening. And you can see when you are swiping the credit card, you want the transaction to happen fast. You don't want to wait too long for that authorization to take place, right? So speed is of essence over here. And speed is of essence for everybody in the chain, for us, for Visa, and your bank as well. Now, having said that, when you're standing in that line trying to pay, and then you keep getting the message, or the merchant comes back and tell you that, I'm sorry, the credit card machine is not working. How is your experience at that time? You don't like it, right? So uptime is absolutely essential for our business. So much so that we are operating all over the world across all time zones, from South America, North America, Europe, and Asia as well. So because of that, us system guys do not get any downtime, no maintenance window for us. It's a 24/7 operation, and there is a transaction happening somewhere in the world all the time, right? So to bring that uptime, traditionally, our current system is on SQL Server, and it has served us great over the years. But based on the growth of our company, really our on-prem data centers are hitting their limits, and so is the SQL Server that it is running on, right? So, and plus, SQL Server is not just SQL Server, but any traditional database, it's not active. So if um, something happens to the primary node, there is a failover process. And while that failover process is happening, the system is down, and which is not good. Even if it takes a few seconds or a minutes, it's not good. So we were looking for a solution where we are able to withstand downtime, not just on a particular primary node, but also what if a region goes down? Something happens, somebody pushes a bad firewall rule and takes on the entire region. We needed something that is still active on other surviving regions and still be able to process the requests. So with keeping that in mind, we evaluated multiple database technologies out there, and a true active solution was with CockroachDB, and that's what we are going with. Don Bosco will give you some more details on what we did.
Hi, this is Don Bosco Wazapali, and I'm lead database principal architect at Global Payments. So, as what I'm going to talk about is our journey of modernization effort at Global Payments, involving moving legacy systems to more scalable, resilient, cloud native, and cloud agnostic architecture. As speakers Ajay and Harsh noted earlier, some common pain points and challenges with legacy systems include scalability issues, single points of failure, high maintenance costs, limited cloud integration, and a lack of agility, and not keeping up the pace with the heavy load demand. So the modernization process using Cockroach offers several benefits, such as improved scalability, enhanced performance, cloud readiness, higher availability, and global distribution. So, what modernization strategies could be used with CockroachDB? So, here are some of the key strategies. Move existing applications with minimal configuration by leveraging CockroachDB's compatibility with PostgreSQL syntax and SQL features. Decompose monolithic applications into microservices with a CockroachDB backend to promote agile development, faster development, and greater modularity. It also helps to, there is also CockroachDB's managed service, which reduces the need to infrastructure maintenance, supports modernization without operational overhead. Implementing a gradual migration strategy that starts with read-heavy workloads or non-critical systems, ultimately moving to a full production with zero downtime. These are some of the key strategies available. So, how CockroachDB enables modernization? CockroachDB facilitates modernization of global payments with the following key points shown in the slide. CockroachDB uses standard SQL, making it familiar to developers and easing the learning curve for teams. It uses distributed SQL architecture. This technology divides data into ranges and distributes it across nodes, managing transactions effectively. It allows for horizontal scaling without any single point of failure. Geographical data partitioning. CockroachDB can partition data based on geography, customer information, or other criteria which reduces latency for distributed applications. Automatic management, it automatically handles data application, rebalancing fault detection, and failover in case of a failure. It seamlessly switches to a healthy replica, minimizing administrative tasks. The system maintains availability even if nodes go down. Again, previously mentioned, it provides strong consistency. CockroachDB ensures strong consistency with isolation. It uses serializable by default and ACID transactions, utilizing draft consensus without compromising performance or data reliability. This guarantees data accuracy even during network partitions. So this slide represents high-level architecture setup at Global Payments, utilizing containers with CockroachDB to ensure high availability. Multi-region cockroach deployment. Deploying CockroachDB in application in a containerized multi-region setup allows for high availability and low latency access across different geographical locations. Configuring CockroachDB for multi-region awareness is essential for applications that require resilience against regional failures and minimize latency for users worldwide. A multi-region CockroachDB deployment using containers provides a resilient and scalable database infrastructure. By strategically configuring replication zones, setting survival goals, and optimizing latency with failover reads, we can ensure the application remains highly available and performs well across all required regions. Container-aware load balancing in CockroachDB. Implementing container-aware load balancing in CockroachDB is vital for effectively distributing traffic across nodes, ensure high availability, and optimizing performance in multi-container and multi-region environments. CockroachDB features built-in mechanisms for handling SQL query routing, but integrating it with container-aware load balancing solutions enhances efficient traffic distribution and resilience. We can achieve a robust, highly available, and low latency CockroachDB deployment across multiple regions with container-aware load balancing. CockroachDB at the core. CockroachDB is a distributed SQL database found on the principles of resilience, scalability, and transactional consistency. It is designed to run globally, distributed applications requiring high availability, low latency, and fault tolerance, making it ideal for mission-critical applications for global payments that demand strong consistency and horizontal scalability. CockroachDB effectively meets the needs of modern applications and suits our modernization effort that requires globally available and highly consistent databases. It merges solid transactional guarantees with a distributed horizontally scalable architecture, making us suitable for applications that need to scale elastically across different geographies and remain operational amidst infrastructure failures. Its compatibility with PostgreSQL and developer-friendly features further establishes it as a powerful solution for cloud-native and globally distributed applications. Ajay?
So what we have done with this one is, excuse me. So what we have done with this one is trying to demonstrate how we have configured CockroachDB. So when starting with the configuration, we tested CockroachDB in VMs on Google Cloud, and we also tested on GKE. Now, if you talk to a lot of people, they think that Kubernetes or GKE is not for database for running the database. It's more stateless and cannot run a database, and it couldn't be further from the truth. CockroachDB works perfectly for GKEs, as it was designed for GKE, and it's Kubernetes maintains the pods with the attached storage, and you don't lose any data with that. What we have done over here is we have users coming in from different parts of the world. There is a user coming from California, New York, and London. We have three regions, US West, US Central, and US East. And we use Google's Cloud DNS, which the users connect to, the point of terminals connect to, and they get routed to the nearest data center based on their physical location or whatever Google decides is the closest. Once it hits the application in that region, now in the same region that the application is, in the same region, we have deployed all the CockroachDB clusters as well. So 3 regions in our case currently, and 3 regions have applications. Those 3 regions also have the CockroachDB clusters. Now, on the CockroachDB layer, there is load balancing. The Kubernetes does its own load balancing. But before that, on a global level, we have also configured Cloud DNS on CockroachDB as well. And all the applications are pointing to the Cloud DNS. And what that gives is Cloud DNS connects to the nearest location. So if the application is east, by default, the nearest location is in the east, and it always connects to the east, right? Makes sense. But if something happens to the CockroachDB cluster in the east, either admin error or whatever reasons, and all the nodes are inaccessible, the Cloud DNS detects that the east region nodes are unhealthy, and the application doesn't go down in the east. It automatically gets routed to the nearest region, whichever is the nearest region automatically. Also, if the CockroachDB clusters in the east are overloaded because of high traffic in the east, for example, we have seen that Google's DNS and load balancing have started routing some traffic to other regions because the apps can scale as much as needed, but the database we have limited to whatever number of nodes we configured. We have configured it not to scale up and down automatically. So if the nodes in the east are hitting the limits, the Cloud DNS and the load balancing automatically starts involving other region nodes automatically, and it works seamlessly without any issues. Keeping it local has also improved the latency that users see and improve the overall time for the application. Talking about data sovereignty, there are built-in features in CockroachDB where, let's say, if I have a region in London in UK and I want to keep the data, London data or UK data in UK itself, then I can use one of the regions in UK, Google's regions in UK, and then I can specify data domicile parameters in my database in those tables that's saying, hey, these if the data matches this criteria, for example, region is in London or whatever, then keep that data in UK only. And those things can be configured within the CockroachDB table level or the database level. And it maintains that automatically without any more user interaction. Users can still access that row from anywhere. And no matter where that row comes from, it will always be saved in the location that you have configured it to be saved. Some of the benchmarks that we did for our new modernized system with CockroachDB. So currently, we hit a peak of around 250 transactions per second. And these are not database transactions, but actual credit card swipes per second. So during the peak hours of the day, We can get as much as 250 credit card swipes, people trying to authorize transactions per second. And that translates to a lot of database transactions. So in the blue system, our legacy system, and if you can see with the modernized system, we see a little bit increase in latency. And that is because now where SQL Server, everything is in one local data center and the ping rates are in 1 millisecond. Now our CockroachDB spans across the United States from west to east. So there are some speed of light limitations that come into the picture, and we see a little bit of higher latency overall in the transaction times. But our throughput went up from 250, and we basically stopped at 1,000. So we easily, with a little bit improve, with a little bit more latency, we saw like a 4 times increase in our throughput, really. So that was, and if you wanted more throughput, it was just a matter of adding more nodes to the cluster to handle that throughput. It's as easy as that. Similarly, we did some chaos testing for resiliency requirements, and we tried to bring down nodes. We tried to just hard shut down nodes in Kubernetes somehow, and Kubernetes brings it back up, right? So it was hard to bring things down when GK is handling things over there. We tried to max out the CPU by sending some bad queries, full table scans and terabyte tables and everything. While doing all these things, we had a full load test running, trying to hit the cluster at 1,000 TPS. And with everything we tried to do, bring down the region, bring down the nodes, interrupt network traffic, and it just kept on going. So we were super excited with that result, basically. So that's what we wanted, really, right? So our application kept on chugging along. When we brought down an entire region, of course, the latency went up a little because like 1/3 of our capacity is missing now, of course, right? So, but as soon as we brought back up, the latency went back down, and it was an easy recovery from there. We also tried to hit our load testing. So again, try to hammer the system. And then we tried to do an upgrade of CockroachDB to a newer version while that load was running, right? Can you imagine that? So imagine doing that with Oracle SQL Server. So when you are doing that during rush hours, again, the application kept on chugging. All the nodes kept on doing a rolling restart. It was beautiful. And same with the schema changes and everything. So everybody was impressed, really, in our company. So it was a big win.
Thank you so much, Ajay and Don, for that overview of how you actually implemented, modernize your infrastructure with on Google Cloud with CockroachDB. It's pretty impressive. You're able to address those challenges with that. So, having said that, we're on the home stretch, and I know there's a lot of questions that are coming in from the audience, and we'll be sure to address them at the end. But I just want to get through a couple of things on our partnership with Google Cloud first. Thank you so much for your patience, everyone. So on that, so today, what Ajay and Don were mentioning, what's being utilized at Global Payments is CockroachDB being deployed on GK. So that form factor itself is the self-hosted form factor, which they can deploy on Google Cloud on GK, Google Kubernetes Engine, across multiple regions. But aside from that, there's a couple of other form factors for managed service options that you also have available on Google as well that you can consume, where you don't have, being a managed service, you don't have to worry about managing it or deploying it. It's all done for you. So if you're familiar with CockroachDB serverless, formerly known as CockroachDB, we have CockroachDB Basic. Basically, it's a auto scale by default type of deployment with multi-region support and on-demand pricing. So you pay as you go. If you have like an ephemeral workload, ideal for those type of testing type use cases, right? Then you have CockroachDB standard, where you get enhanced features such as private connectivity between the services to enhance security, custom region support as well, while consolidating a variety of production workloads, while making sure that you optimize the cost for that as well. So that's CockroachDB standard. And what was formerly known as CockroachDB dedicated, now CockroachDB advanced, it gives you, a full like dedicated infrastructure as a managed service with, you know, c- you know, features such as PCI support, CME kick. You can bring your own encryption keys, egress perimeter controls, HIPAA compliance with, more regions, custom regions also available, and being able to deploy on dedicated hardware on, you know, on Google Cloud as a managed service. So you get, you know, as a user, I feel like that's a great, like, if you don't want to manage your own infrastructure, you still want to leverage the cloud, and you don't want to manage the database in terms of how it's on. That's a great option there. So those are a couple of deployment options that you get with CockroachDB on Google Cloud. But beyond, what we shared so far, like, how do we integrate into the rest of the Google ecosystem? Let's say you're using Google Cloud today. What other services can you use with CockroachDB, right? So right now, like, let's say you have your applications, your APIs, your serverless functions interacting with your database. With our native CDC capabilities or change feed capabilities, we can integrate directly with PubSub, and through there, you can create a BigQuery subscription to get data into BigQuery to leverage further integrations with machine learning via Vertex AI and Gemini. But also from there, you can do a lot of BI functions with Looker as well. And we support, GCS as for your cloud backups as well. Especially, let's say today, CockroachDB is deployed on multiple regions on Google Cloud for global payments. They can create locality-aware backups on Google Cloud Storage. So they can create, like, for their specific region, they can create um, backup for that specific region in a cloud bucket in that specific region. So that way, those backups are locality aware. They know, which region they're trying to support for that backup, and when let's for some reason you need to do a restore, it's all done seamlessly. So you don't have to worry about distributing your data again, and those sort of things. And of course, with Google Cloud Monitoring and Logging, we have a CockroachDB has excellent metrics that we already provide you. But if you need to increase that scope further, you can use the monitoring and logging features that you get with Google Cloud as well to make customized dashboards for your organization and your requirements specifically. And specifically with some use cases, right? Like, how does that actually work? So you have your applications that interact with CockroachDB through, APIs and serverless functions. They connect through the load balancer, like what Ajay was talking about earlier. Either your CockroachDB instances are deployed on GKE or GCE, or the compute engines that Google provides, and through our CDC functionality, you can connect into PubSub and create a BigQuery subscription to get data into Google BigQuery. And the best part about that is it's no code required. It's pretty straightforward. And with BigQuery ML, you can leverage Vertex AI, Gemini, as well as you can also, through BigQuery, you can also tie that into BI visualization using Looker as well. So those are ways that you can further integrate into the Google ecosystem as well. Not just using Google for as your compute, but also the variety of the first-party services that you have with Google to further make the most out of the data that is basically stored on your operational data store, which is CockroachDB. And why CockroachDB on Google Cloud, right? So I'm going to keep it short here. It's available on the GCP marketplace. It's very easy to procure through there. Available as self-hosted and fully managed. You remember the form factors I went through earlier. It's there. If you are an organization that's looking to burn, your Google commit, that's a great way to do it. Purchase it off of the marketplace. It's a simplified procurement process, right? But the real value here is that strong integration with the core Google services to get the most off your data. We're integrated with GKE, GCE, PubSub, BigQuery, and all those other services. So you can really get the most out of the broader ecosystem when you're deploying CockroachDB on Google. So having said that, I want to, keep it if you want to, see what that listing looks like on the marketplace, I'm going to keep the slide available. But at the same time, I want to take the remainder of our time here to answer some of the questions that we had in chat as well. So in no particular order, we had one from Andrew Cooper. So I hope I'm not I'm pronouncing it okay. But does the write throughput reduce proportionally to scaling due to the need to maintain consistency via consensus? So, so with CockroachDB, because we do consensus-based transaction, there are slight, as what Ajay was talking about in terms of performance, right? Latency that will increase, but in terms of the throughput of the transactions that you're doing, you can scale that quite a bit at the same time. So it doesn't necessarily like it's a slight trade-off that you're making when you're dealing with the latency to process and transaction, but you're really scaling up the volume of those transactions at the same time. I hope that answers the part of the question. I can obviously follow up with on providing links and how to best architect and use CockroachDB features to do that. How does one maintain local? Mahendra asked, how does one maintain local data jurisdiction regulations? So again, Ajay, I think you spoke to this as well on how you're using the CockroachDB features to do that, but I can also take a stab at it. What you can do with CockroachDB is we have different native features such as data domiciling and creating super regions to support data and pin data to specific geographies that you can take advantage of. But beyond that, there's different type of tables and table types that are available within CockroachDB. Not to get too technical with it, you have the option of using global tables, regional by row tables, and by using those, especially with regional by row tables, what you can do is you can basically add a column within your database that basically translates to the region that you want to pin your data to. And using that column, the value in that column, CockroachDB automatically stores that row for that table in that specific region. So you don't have to really do a lot of manual operations beyond that. It's all done by you through CockroachDB to pin data to that specific region. Now, depending on the type of regulations that you want to comply with, your experience on how you would do it would be different than what I just said. But that's generally the way that you would go about it. I hope that answers the question there. We also have, how do I get CockroachDB as a database? You can scan it over here, or you can go on to cockroachlabs.com and you can get it in Europe as well. We're available like globally as a database, so hopefully it should not be an issue. Ranjan asks, how much time does your deployment take for AZ failure and region failure? The lease has to move from one node to another. How long does it take in your cluster, and how much is your SLA? So Ranjan, is that specific to global payments or more like a general question? I can take a stab at answering it from the general perspective. So let's say I'm trying to bring up a reference slide over here. Okay. So let's say you have a globally distributed database that you see here across multiple regions, right? And let's treat this as different regions. Let's say your US region failed. The way that CockroachDB would do is, let's say you had the minimum number of required replicas for your CockroachDB database. You would have a copy of you'd have a copy in all three regions, and because you have three regions, you would have like three copies across the database. So if one of your region went down, you'd still have a majority available. Now, how long does it consider that region to be down, or consider it's down? It's basically a 5-minute window where if that region is not available, CockroachDB will keep that region and the nodes within that region specifically as suspect, but it will be still able to process transactions because you still have a majority available. So in essence, as a user, you won't experience downtime when your applications are interfacing with the database. Even if you had a region failure, what would happen is generally through the load balancer, you won't be directed to that region because the nodes won't be available to process those transactions. You'll be sent to the remaining regions that are available to do that. So I hope that, at least at a higher level, answers your question. So Greg asks, how long has global payments been on Cockroach? How many payments is it currently pushing across this infrastructure? So I know Ajay mentioned 250 transactions per second, but Ajay, do you have any, you want to take a stab at this question?
Right. So we are not fully there yet. We are in the process of productionalizing our mod system. So it's more of a pre-prod stage where we are only routing or mirroring a part of a very small section of a traffic just to make sure our setup is correct and iron out any issues over there. So yes.
All right. Thanks, Ajay. Okay, so Sangeet asks, how are handling increased write latencies when replicas distributed across globe if you don't have a data model that does not support locality to create regional partitions? In that case, table will technically be a global table. So generally, the way that you want to think about it is, because we implement consensus-based transactions, you need a majority of the replicas to participate in that transaction for it to be considered complete. So in a way to manage latencies, what you can do in that sense, even if you have a global table, is have select regions, and where regions are generally closer to each other. For essence, let's say in this diagram that you see on screen, from left to right, it's west, central, and east. Let's say if we're processing a transaction on the West Coast, the latency in effect wouldn't be from the west to the east. It would be from the west, where the first replica resides, and the next closest replica, because that would consist a majority that would participate in this transaction. So that way you can create a topology where, based on how many replicas you have, a majority stay closer to each other to decrease that transactional write latencies, even if you have global tables. Now, if you're dealing with regional and other tables where you're optimizing those things, obviously that's a whole different story, but that's how you can, from the architecture perspective, approach that to do. So Pavel asks, have you used something like TPCC to measure performance limits? Yes, we have. We actually do have performance benchmarks that we recently created a blog on. Let me see if I can, first of all, add something in the link here to answer your question, but I can certainly create a follow-up to, if you basically look at CockroachDB, Google CockroachDB benchmarks, you're able to find the benchmarks and type of testing that we do with different type of benchmarks and what their performance has been like on the different size of clusters, be it single region, multi-region, and whatnot. I'll try to find that for you shortly, Paul. So have you tested split brain scenario? Could you elaborate on that as well? So ACID and distributed database system, what is the trade-off? So over here, generally the way that transactions occur in CockroachDB is, what we do is, of course, consensus-based transactions. So let's say if you have, I don't have a slide with me on that right now, but let's say you have a 3-node cluster. Let's see if I can have a reference slide. Let's say I have a 3-node cluster and I have a read that goes in. Any node within CockroachDB can basically act as a gateway node, but only the leaseholder, which is basically the lead replica, which handles the data for that range, is able to respond to, instantly able to respond to read requests for that. That's where the read request would go in, and immediately, without requiring consensus, it would provide those details, because for that sort of operation, you won't require consensus to do, because it's already updated for that subsection on that lease. But let's say you have a write operation. So in case if it's a write operation that you're doing, it's going through any one of those nodes, but depending on which lease that it needs to write into, it's sent to that leaseholder, and the leaseholder then updates itself, and it sends that same operation to the two remaining replicas, and then it waits for one of them, at least one of them, to reply back with, "Hey, I've completed an update on my lease as well. I've written this record into my lease." At that point, you have consensus in the sense that you have a majority of your replicas are already updated. So at that point, the transaction is told to be complete to the client. And then the third copy, because it's never going to be responding to any read requests anyway, it can be eventually consistent. By eventually consistent, what I mean is it might be a couple of milliseconds behind even the second node, but because it's never responsible for responding to read requests, that is fine. So you're not getting a dirty read or something like that in that sense. So we have like an architectural guide within our docs which explains that in detail and how we do that. I can certainly point you towards that as well. Josephine, how does this work with GKE mesh? I would have to get back to you on that. I don't know from the top of my head, but I'm pretty certain we have done some testing from the engineering side. I'm just not sure what the exact status of that is. All right, so then I'm just going through a bunch of questions in chat over here. So what load balancer work well with CockroachDB? So generally with CockroachDB, your network load balancers that you have available with Google Cloud work well. You can also use HA proxy or something like that. Generally, it doesn't really matter too much, but we have that documented on our implementation guide as well. But with Google Cloud, your network load balancers that you have there, and your basically cloud load balancers and HA proxy, you could potentially use with that. So Paul also asked, does CRDB best practice to use big number of small nodes or small number of fat nodes? So what we recommend is use a larger number of nodes that are smaller rather than a small number of fat nodes, because we are a distributed system. We want to distribute the scale across the different nodes. So that way, let's say you had an unplanned failure on one of the nodes, it doesn't affect your cluster in that much proportion as well. But at the same time, a single node isn't in direct proportion to being affecting your work, like your running work with that in terms of performance and whatnot. As Krishna asks, are there native connectors or adapters for standard market APM tools like New Relic, AppDynamics, Datadog? Yes, we do. So basically, I'm not sure if this is the protocol or what we use, and this is not my exact domain, but we do have an integration with Datadog as well as you can use Google services as well to get metrics off of CockroachDB. But we also provide telemetry support through I believe it's in tracing or something along those lines to use. But yeah, Ajay, you want to
And
add in?
Prometheus, it supports Prometheus too. So
Yeah,
anything that supports Prometheus.
yeah, exactly. So does CockroachDB have separate endpoints for reads and writes? No, it's generally you're going to go through the load balancer endpoint, and it's going to distribute it across the cluster. You don't have to worry about the separate endpoints specifically, because any node within CockroachDB can act as a gateway node to process that transaction. But beyond that, yeah, it should be pretty straightforward. You don't have to worry about managing separate endpoints to separately process reads and writes. Yeah. All right. You manage same table. Yeah, Sunil asked, how do you manage same table and data that need to be updated in different data centers? So we kind of touched upon how transactions and everything occur, but yeah, the latency is limited to that speed of light limit that we have. Yes, that is correct. So, question for you, Ajay. Do you use cluster mesh or Cilium if you run CockroachDB on Kubernetes/GKE?
I do not know. Sorry. Our cloud guys will know that.
Yeah, we can get back to you, Paul. How long does it take to replicate data into a new node zone region? I know it depends on DB size. So great question, Andreas. Generally, so there is a rule of thumb which I don't recall from the top of my head. It should be in our documents, but generally there is um, uh, we allocate some amount of CPU utilization from these nodes to, let's say you add a new node and you need to account for background services and whatnot. That's what's used to do that. What that rule of thumb kind of translates into, I will have to get back to you. But yes, we have something on that. Pavel asks, do you provide any tooling for migrations? Yes, we do. We provide so we have native services basically called Molt and Molt Fetch, basically where we support and schema conversion tools where, let's say you today you're on a different database than CockroachDB and you want to migrate towards CockroachDB. You can use those tools to, first of all, define your schema from your current database to your destination database in this CockroachDB, what that would look like. And beyond that, you could use those basically our inbuilt tools that we provide to assist with that automated migration as well, and make that simpler for you. How long? Okay, so Benjamin asks, how many copies of data do you keep in 9-node cross-region setup? That's a good question. So it depends on your survivability goals as well. Benjamin, I'm guessing if you have 9 nodes and a cross-region setup, so you're thinking 3 regions and 3 regions in each node. So depending on the type of um, failure event or performance that you want to get to, that's how you decide on the number of copies of data that you want to keep. At a minimum, you're going to require 3 copies, and what that would do is it'd give you the minimum of a copy across each region, and that allows for regional resilience if one region goes down. But if you want to go beyond that, then certainly you can increase the number of copies and distribute them across that, let's say, different regions to achieve higher resiliency as well as performance, depending on how many voting replicas and whatnot that you have to take part in those transactions. So I know there's still a lot more questions that we have in chat, but thank you all for joining. We're about time, but if you need to reach out to me, and our team here at Cockroach Labs, feel free to reach out. To me on email. It's my first name, Hirsch at cockroachlabs.com. I'll leave it in the chat for folks.